Do you want to learn how to perform 2D navigation with a drone? Then stay with me. This video is for you.
Hello ROS developers and welcome to ROS Questions and Answers video series. If you want to learn anything about ROS, this is your channel. ROS navigation, ROS with drones, ROS for autonomous cars. Everything ROS is here. Learn ROS step by step and push your ROS learning in just 10 minutes of video. I am Alberto and today we're going to continue with the drone 2D navigation series. But before anything else, remember to visit our Robot Ignite Academy, our online academy where you will find practical online ROS courses using simulated robots, no installation required. You will find a link to the academy on the video description. And yeah, so now let's go for the video. Let's go to RDS, to ROSDS as always. And today we are going to be doing the path planning video. So let's open here our ROSjet, Drone 2D Navigation. We left it in the last video with the localization system working. So we are going to pick it from there and we are going to build the path planning system. So all the launchers for the move base node, etc. And we are going to be following the same structure. So we are going to use already made files, launches. Then let's open first of all a shell, an IDE as well to visualize our files. There we are. Here we have our quadrotor navigation with the quadrotor localization launch or the mapping launch. So let's go to the tractable navigation. And here we have in the includes, I think, yeah, here we have the move base launch file. So we are going to take this one and we are going to paste it to our package, quadrotor navigation launch. There we go. So now we will have it here. Excellent. And also, let me first of all rename this file. So I'm going to call it, following the convention, quadrotor movebase.launch. There we are. Yeah, here we have it. So as you might see here, we are loading many parameter files, which are here inside this param folder. So I'm going to copy as well this parameter file into my package. So let's go up. And here we have the param folder with all these parameter files. Not all of them are used, but well, I'm just going to copy all of them. Well, actually, let's just copy the ones we need, so anyone gets confused. So let's have a look here, and we are using the cosmap common, local cosmap, and global cosmap. So cosmap, sorry, I have to go inside here, and cp cosmap common, cp local cosmap, global cosmap. Then DWA local planner is another one, move base params, global planner, and nav fn global planner, and I think that's all. So let's copy all of these to our package. Param. Okay. So let's create here the folder. There we have it. Okay, and now I will have all these parameter files here. Excellent. So now I have the launch file here, so I will have to tune it, as always. So first of all, I'm going to get rid of this. I think it's not necessary for this case, so I'm just going to comment these lines. Then all these startable navigation package names, we can change it for quadrotor navigation, which is our package. So here we're going to just do a find of Turtlebot, and we are going to replace it with quadrator. There we are, replace all. Excellent. Now here I have another file, which is the dummy, which I haven't copied, so I'm going to copy it right now. Dummy to... Okay, there we have it. Then let's review all these frames, topics, etc. So first of all, we have the add-on frame, which, as you already know from other launch files, it is world. Then the base frame ID is base footprint, so nothing to change here. The global frame ID is also map, this is correct. Then we have the add-on topic, which we are going to see right now. We have the laser topic, which we already know as well, it's scan, yeah? Here we have it. Then what are we going to do with the add-on topic? Because, let me launch 1 second the simulation here. There it is. It's almost loaded. So yeah, we are going to check now the topics of this simulation. Let me minimize here the logs. There we have it. Then now if here I do a ROS topic list, or I do a ROS topic list and search for some odometry or anything like this, we don't have nothing. So we don't have any topic which, like we have here, it is named odom. Then what are we going to do? In this case, in our simulation, we have the ground truth, which we can use as an odometry. So here you have it, this ground truth state topic. Yeah. So if we have a look into this topic, ground truth state, you will see that this is using odometry messages basically. So we can use this as an odometry. Yeah. Let's do an echo. So as you can see, this is using messages which are the same as an odometry message, with the pose, the position orientation, covariance, and the twist. Yeah? The linear and the angular and the covariance. So this is the same as an odometry message and a regular odometry message. So what we are going to do is to use this topic as our odometry. Then, yeah, so we are going to put this here. Ground. Actually, let me copy it so that I don't add any mistake here. Okay, here we have it. And excellent, so we have our launch file ready with everything correctly remapped. And now what we are going to have a look is to these configuration files, because probably we'll have to do some modifications here as well. So let's start with the cost map common. And here, well, here you can tune it in order to modify the behavior of the move base node and the cost maps, etc. Everything involved in path planning. But for what we are concerned, we basically have to look out for frames, topic names, etc. Because this is what it may be, we might need to change. So, for instance, here we have the topic of the laser, which we are going to change for scan. This is exactly the same we have done here, yeah? So our laser readings will be read from the scan topic, yeah? Then we are not using any point cloud here, so we don't have to worry about this. So basically, yeah, this will be, we have the scan topic. So let's save here our cost map common params file. Let's go to the local planner, DWA. Here, as you can see, everything are velocities, maximum velocity in X, minimum velocity in X. So all this is to control the velocities of our drone. But we don't have to change it in order to make it work. So as you can see, all of these alter trajectory scoring parameters. Okay, so well, here we have a global frame ID, which we are going to use map. So let's modify this, and that's all. Let's move to the global cost map params. Here we have the global frame map and the base frame as base footprint, so this is okay. The global planner as well. Here we have nothing, any topic or any frame that we need to change, so this is good as well. Then for the local cost map, we are going to modify here the global frame for map. The base footprint is okay, and everything else as well is okay. You can change it, but in order to improve the performance, but it's not required. So yeah, this file is also okay. Let's start closing all this. Then the move base params, here we have also frequencies, timeouts, the local planner we are going to use, which is the DWA, the global planner that we are going to use, which is NAV FN. Nothing to change here. Okay, and finally the global planner, which probably we don't need to change anything. No, we don't need to. So yeah, I think everything is correctly remapped and modified now. So let's test this. Let's launch our launch file. Quadrotor navigation, quadrotor move base dot launch, and we are going to open RVs, of course, in order to visualize everything properly. So this is starting all the system. Okay. So here it's complaining that the target frame map does not exist, and that's true because we are not publishing the map anywhere. So here we are launching the move base node. Sorry, here we are launching the move base node, as you can see here, but we are not launching the map server anywhere, nor the localization system. So one thing we will need to do here is to include for instance, we can include the quadrotor localization launch file, because here we are launching the AMCL system, the localization system, and the map server. So what we are going to do is to include this localization launch file into our move base launch file. So let's remove this, and here we have quadrotor localization dot launch. There we are. Okay. So now we are going to first launch the localization launch file, which includes the map server and the AMCL system. And then we are going to start all the move base node, yeah, which will be in charge of the path planning. Then let's start again. Let's relaunch this. Let's start here RVs. Okay, so as you can see here, it is launching properly. It's not complaining. Then let's start here graphical tools. There we are. Let's close it here. Okay, yeah, here we have it. Great. So now let's open our configuration file, which we had in our package in the RVs folder for the mapping. Great. Let's add here a couple of things. Let's add first of all the pose array in order to visualize localization. Here the map. Let me duplicate this. And I'm going to add here a global cost map, for instance. Here we have it with the inflation and everything, as you can see. And finally, let me just add the pulsar array, let me configure it properly. This is particle cloud. Great, there we have it. And finally, let me add here a path visualization in order to visualize the path that the robot is following. For instance, let's visualize the global plan, which is this one, the FN. So yeah, this is ready to go. So what we are going to do now is to directly send a goal to our drone, and let's see if everything works properly. So let's send our drone, for instance, here. As you can see here in green, the path is created. Oh, okay, let me just take off the drone first. If I don't do that, obviously, the path planning system is not able to automatically take off the drone by itself. So I have to take it off. So let's do that very quickly. ROS topic pub, take off. There we are. As you can see, the drone is starting to rotate. Okay. There it is starting to go towards the goal, but it hasn't finished to take off properly. So that's why it's a little bit strange. it's flying almost on the ground level, but well, it's going towards the goal, as you can see. So now I will take it off properly. Yeah, it's almost there, as you can see. Let's see if it has reached the goal. Go reach it. Yeah, great. So it has reached the goal. Now let me just land it and take it off again so that it goes a bit. Well, it doesn't matter really for this purpose, because all we want to see is that the path planning works, which does. But well, anyways, let's take it off properly. There it goes. Okay, now it is high enough. And yeah, so as you have seen, the first goal has been properly reached. It has done here some clearing cost maps in order to unstuck the robot, but everything went okay. So yeah, you can now from here start sending navigation goals. For instance, no, let's send the drone inside here, and here the path you can see in green, the global path is generated, and the drone starts heading towards that goal. We can see it here in RVs, but in the simulation as well. There it is. It's starting to go there, as you can see. There we have it. Let's put this, because this way we cannot see it very well. It seems like it is going to crash, but the robot is okay, as you can see. And yeah, it has reached the goal, I think. Yeah, here we have it, goal reached. So yeah, our path system is working properly. You can tune it as you want. As you have already seen, there are many parameters. We have a course, in fact, in the Ignite Academy about ROS navigation, where you can see what are the most important parameters of all of this, how you can tune it, what will affect modifying these parameters, etc. But for this video, we have seen that this is working, so we are going to leave it here. And remember that in the next video, I'm going to be answering a very interesting question we got in the first video of the drone navigation, which was this one. A user here asked how it is possible to use, so it says here you have simply used world frame as odometry, which is true, which Gazebo is publishing, but in real world we have to publish it by ourselves, considering its implementation on a real drone, then what we can use to get the odometry data. So in the next video I'm going to show you how you can get odometry data, which is not from the frame world, which is published by Gazebo, so it's kind of a simulation trick. So we are going to see how we can, from camera readings, how we can publish an odometry that we can use in navigation. So this will be for the next video. And yeah, that's all. If you have liked the video, please give us a thumbs up. Remember to subscribe to our channel. We are publishing videos almost every day. And yeah, any comments, thoughts, leave it down below in the comments area. And remember that I have shared also in the description of the video the project with this exact same code I'm using here. In fact, I'm going to save this now. And I will share this project with exactly everything the same as I have it here, with these launch files, these parameter files. Everything will be exactly the same, so that you will be able to reproduce this by yourselves. And I will place the link of this project in the description area. So yeah, goodbye and see you in the next video.